how the developers use the information that is in the context broker, the context information, right? You have developers that may use this as a user interface for desktop, mobile, tablet, etc. They might be using as well any of the GEs that help on creating advanced user interfaces like the Web3D GE or the WireCloud GE that helps you to create dashboards. And then you have also the possibility to use the context information from the context broker directly in your backend that might be in the FIWARE cloud or in any other server in the internet. So as you know, the target of FIWARE are developers. And from this point of view, there are two kinds of developers in IoT. There are what we call IoT consumers, right? That are those ones that just want to consume IoT information. They are not so much interested in providing information from their devices. And what we call IoT providers, which are the ones that connect devices, connect IoT information in the end. So for the first ones, what we saw is that they are not just normally interested on consuming IoT information. They are willing to consume any kind of information that you can see on the slide. And for them, we provide the context broker as a single point, single API, single protocol. As you know, the context broker models any reality that you want to model as entities with their attributes and metadata, right? So this is exactly the way you can model IoT information as well. You can have an entity per each one of the devices, or you may have an entity per a complex thing, like a room, for instance, and then you calculate the temperature of the room as an average of the 3 temperature sensors. And you might be using a public context broker, so you publish the information and everybody would be able to consume that, or you might be using a private instance of the context broker. Then we have what we call the IoT providers. And what we see here is that in this context of IoT providers, it's pretty heterogeneous in terms of solutions and skills. This means that many IoT providers or integrators, they are using very different technologies because there is no convergence at all in the southbound of IoT, as you probably know. And also there are very different skills. I mean, there are just web developers that they just want to connect a very simple device and they just want to see the data in a context broker or in their application. But there are others that are dealing with complex sensor networks. They want to manage the gateways, they want to manage the networks, they want to operate these networks in real time, etc. So what we offer as FIWARE is a KISS philosophy that means keep it simple, and I think and stupid, they say, right? So it should be easy for somebody to connect in a simple way a device, but it should be also to tackle more advanced scenarios. So this is more or less our goal. And as I've been talking about consumers, which kind of information you can be consuming from the context broker. If you go to the public context broker that we have in the FIWARE lab, you will see that there are many cities connected. They are not only providing IoT data, but they are also providing OpenData as well. And here you have several cities in Spain where we started, like Santander, that you know that is probably the most sensorized city in the world with up to 15K sensors deployed on field. You have Malaga, you have Seville, you have cities in Italy like Trento, and we are connecting cities in Finland like Espoo and Helsinki, and in Portugal like Lisbon. We are setting up as well nodes in Mexico for the sake of Mexican developers, and also another one in Brazil and in Chile. So we expect other smart cities in those areas to come up as well. So if you just want to consume IoT data, you don't need this presentation at all, right? You just need to go to the presentation of Fermin yesterday. It's just context information that you will see in the context broker. And the only thing I need to provide you is with the conventions that we use to name the devices as entities in the context broker. So you have a couple of examples here. For instance, for Smart Santander, you have the type of the entities is Santander : traffic, for instance, for the traffic sensors. And in the case of Seville, you have water measurement sensors in several homes, but it's anonymized data, of course. And you have Seville : water. You don't need to know these conventions, although these conventions are more or less updated in the document that is linked down, where nobody can read this link, even myself. But this presentation is in a slide share. So you could just click on there and you would get to this document. And the other way to do the same thing is to access the context broker and use the discovery facilities. And I'm not going to extend on that because I assume Fermin was explaining that yesterday. But basically, you can discover all the entity types that there are in a specific service in a context broker, and then you can recover all the entity IDs of a specific entity type. So with that, you could be retrieving all the entities. I see a question here.
Could you slow down a little bit? So 10% less rapid.
Oh, okay. Okay, perfect. I'll try, right? What you didn't get so far? What you didn't get so far?
I get it, but it's taking a long, much concentration.
All right.
I don't stay all day.
Okay, okay. I'll try to slow down a little bit. Okay. Let me make a try. You get me again if you feel I'm going quick. So for the IoT providers, which is the main topic of this presentation, this is to connect anything to FIWARE Lab. We may have three options, right? The first one would be to develop yourself an adapter of NGSI, so you can do what we call a backend to backend connection. This is because we have found many cities, they come to us, they say, look, I have hired this garbage collection system to this company, and they will not provide you access to their sensor networks, they will not provide you access to the gateways, etc. But they want to provide the data, because I'm the owner of the data as a city, and I want to provide this to your platform. So in this case, they just develop the NGSI connector, and they connect directly to the context broker. This is not IoT stuff, right? You are providing IoT information, but it's done in a very simple way. You use a FIWARE specific protocol, which is NGSI. Second option, which is the main topic of this presentation, right, would be to use a standard IoT protocol, and then you use the IoT backend device management GE, which is the IDaaS in the end, right, to translate this protocol into NGSI. And it will connect this to a context broker, being the public one or a private one that you have deployed yourself, sorry. And then that is all done, right? So this is the main case today. You will be using IoT standard or IoT protocol at the southbound. You will get this protocol translated into NGSI because of the IoT backend GE. And this will connect to a context broker. So you and other developers, if you want so, will be able to access the information at the context broker. Then there is a third leg that is the advanced scenarios, but I'm not going into the details today. Okay? Is it clear? Better? So if you go to the FIWARE wiki, look, for the IoT, we are making a huge upgrade now. So because of the release of the IoT-Agents. So I would recommend you not to check this until 2-3 weeks, until the end of the month, right? Because everything will change, but it's exactly as I'm telling in this presentation. So you better use this presentation and the one that my colleague Daniel is going to do on Thursday regarding advanced IoT. But if you're interested in a wiki, you see several GEs, and what I'm talking about is exactly this one that is in the red circle, right? This backend device management GE, which we call IDaaS. And this is the architecture of IDaaS that we will place in the wiki soon as well. The point is that IDaaS was a typical telco component for advanced and added value scenarios. So it was a classical monolithic component with a proprietary API, and it was thought to work with the telco itself and the partners of the telco, right? So it was extensible. I mean, you could add new protocols, but it was done with plugins, with C++ plugins. So then you needed to code these plugins in C++, and at the same time, you had to wait for a, let's say, coordination window with us in order to perform the integration tests and perform the delivery in the end. But now we have replaced this monolithic architecture by a modular architecture that we call IoT-Agents. And this is why the installation is becoming much easier. This we did actually because the feedback of all developers in FIWARE, right? We realized that when we open sourced IDaaS and we went to a large community like FIWARE developers, you could not go with that monolithic component, with that kind of extensibility and etc., right? So we decided to refactor totally the component to make the installation really easy, and you will see that it's really so, and to focus on the main task of this GE, that is to translate the IoT protocol into NGSI. And that's it, right? Because before IDaaS had much more functionalities that we have been spreading in other parts of the platform. So there are several IoT agents, and the IoT agent that you would be using depends on the protocol that you will use. I'm not going to show you all the available IoT protocols today, because if you work in the field of IoT, you know that there are really a long list of protocols, and there are many alliances, industrial alliances as well, and SDOs, standardization bodies, that are pushing for different protocols, right? So it's not an easy task. But let's guess that you have already selected a protocol, right? Then you just need to select the correct IoT agent. Or if you are using a proprietary protocol or a new standard that we are not supporting, my colleague Daniel will explain on Thursday how to make your own IoT agent, because we've developed a skeleton in Node.js, so you can be doing your own translator, right? But overall, our main goal is that you shouldn't need to do this. So, which protocols we are supporting today? We are supporting Ultralight 2.0 over HTTP, right? Ultralight 2.0 is a reduction of the sensor ML. Sensor ML was developed by the NASA a long time ago. It was very complex, very heavy, and prototype specification language for devices and their observations and commands. So we are using Ultralight 2.0. Ultralight 2.0 is not the standard in any standardization body, but it's extremely simple, and it works pretty well, right? So this is why we selected Ultralight 2.0. But we are implementing as well MQTT, and we are implementing as well lightweight M2M over CoAP, that you know is one of the recommendations at the southbound for one M2M and other alliances. So I'm going to explain today the one in the red circle, that is Ultralight 2.0 over HTTP. This is oriented to the most simple case of developers. I mean, you have devices, you have gateways, you can code your software in the gateways, and then you can connect them in a very easy way. Actually, we are providing some scripts in Python to do this task. So if your gateway or platform supports Python 2.7, you will be doing this in seconds. And my colleague Daniel will be explaining on Thursday the IoT agent for lightweight M2M over CoAP, right? That is pretty much advanced and is pretty much aligned with the standards. So this is overall the architecture of what we have deployed in the FIWARE lab for your convenience, right? To use this as a service. By the time being, I would recommend please use this as a service until we have all the IoT agents deployed and available for you in the GitHub repository. For your information, the lightweight M2M over CoAP, it's already in GitHub, and Daniel will show you on Thursday. And the one that I'm explaining today, you should be using as a service, because we are going to place it on GitHub by the end of this month, right? Together with all the documentation in the FIWARE wiki. But you can use these slides as the document to work already with this. So basically, we have several IDaaS instances, right, that we connect to different context brokers. They are all public, and they are finally all connected to a single context broker. You may access each one of these context brokers or the global one. I would recommend to use the specific ones, because then you don't create so much overload in the global one. But we are not having scalability problems there, so you can do any way or the other. And for each instance of IDaaS, of the IoT agent of Ultralight 2.0 that I'm explaining today, you have different services. And this is made to secure that only the sensors from one customer environment or city go exactly to that service. So the devices need to know a shared secret that we call API key. We call API key. Sorry, API key. So we have a service for the city of Seville where they are pushing all their information. We have a service in another IDaaS for the city of Santander, and we have another service which we call Open IoT that is available for all of you. And later in the next slide, you will see the shared secret. So you could be using this right today. And in the case you would need a specific service for your application or your company business, we can create the service for you, right? And in some weeks, you will be able to install or to deploy the IoT agent yourself, and then create the service yourself, etc. So let me go in how the scripts that I mentioned are used. There are two alternatives to use this Ultralight 2.0 IoT agent. First, to know the HTTP post or gets that you need to access to it, right? Or you might be using what we call FIGWAY, which are these Python 2.7 tools, and they are available in this GitHub repository. I strongly recommend you, for your first contact with the platform, to use FIGWAY, right? FIGWAY is just very simple tools, and then you just create virtual sensors from your laptop. You can also run this in a Raspberry Pi or any other platform that supports Python 2.7. So in the exercises, in the labs that start today, I think today in the afternoon, we place exercises where you can use FIGWAY to create your virtual sensors, your virtual actuators, send observations, and get all this information in the context broker, right? So to get experience with this. But if you have some platform that is not supporting Python 2.7 because maybe it's a very constrained device, or you are working directly with Arduino, for instance, then you can code the HTTP posts that I will show later. So normally I started with the HTTP post, but this time I choose to go directly into FIGWAY because I think it's much easier. So the first thing to get to FIGWAY is to download this or to clone this from the GitHub to your laptop. And there is only one configuration file. Everything is explained in the README. And the only thing that you need to know in this config ini file is that you have to place your username, which is your username in the FIWARE lab account that they were explaining in the presentation before, and the OAuth token, right? And this is because, of course, there is an IDM protection, an IDM proxy between you and the IoT agent. So in case you don't have the OAuth 2.0, we have a script as well that is available in the same repository that is called getToken, and you just put your username and your password, and you get a valid OAuth token. I think it lasts for 2 months, so you have enough time to play with it. And then another part of the configuration is the host type. It's a free format. You just need to clarify which platform you're using, for instance, Raspberry Pi, Mac OS, Windows, etc. And the host ID. The host ID is important because it's the way to distinguish your devices from others, because you are using the OpenIoT common service. If you would be using a specific service for you, you would not need this specific configuration. And for the host ID, you might be using your email address or something like that, but I normally recommend to use, for instance, the 3 lower bytes of your MAC address in the computer you're using. This is a nice way to have a unique identifier. So once you have configured this file, we can go directly into the sensors or devices creation. So the first thing is to register a device. And there is a command for this. You just need to provide the model of device that you are creating, the name of the device, and the name of the asset. Look, for a device, we define 2 names. A name at the southbound that we call device ID, and a name at the northbound that we call asset ID. This is because imagine that in this room we have a network of sensors. So for you as an IoT integrator, you may have meaningful names for you, like temperature sensor in this gateway and with this vendor and model. For instance, Arduino O2 dot gateway O2 dot temperature sensor. This is meaningful for you. But later on, when a developer is going to access the information, they don't need this information. They need a very simple name, something like, I don't know, university, room 1A, sensor temperature sensor. That's it, right? So we have these 2 names. The name that you will expose to developers, that is the asset name, and the device name, that is the name that you will use. As a benefit, if you change the device because it breaks down, then you can keep the same asset name, right? So developers will not see any change, but you may change the device and may change the name because maybe you changed the sensor model or vendor, etc. So the only thing that you need to do is to run this command, register device. For instance, I will create a temperature sensor, right? Now I will tell you tell you later where are the different models of devices. So for instance, sensor temp _ temp is the temperature sensor. Then I give a meaningful name for me, sensor 1. Maybe I have just 3 sensors, so sensor 1, sensor 2, sensor 3. And then I give a meaningful name for a developer, temperature, hyphen, Madrid, and a district code, right? And then the command gets to the device ID, asset ID, and entity ID that I will see in the context broker. The device ID will be the same name that you selected, but it appends in the beginning the host ID, right? The asset ID is the asset name that you choose, but it appends in the beginning also the host ID, so we differentiate from your devices and other people devices. And then the entity ID is the device model, point, the asset ID, right? You don't need to memorize this, because when you run the command, you get the device ID, the asset ID, and the entity ID. So you just copy paste, right? It's very simple. So to identify the device, you will have the 3 IDs. The ID at the southbound, the ID at the northbound, and the entity ID in the context broker. In the next version, the asset ID and the entity ID will be the same ID, right? Because we got this comment, from developers, and we will be doing so. But at the time being, it's exactly as I'm showing here. And then once you have registered the device, you just need to send the observations. And in Ultralight 2.0, it's extremely easy. You send the alias of the observation. For temperature is T, right? Bar and the value. And this is why we are using Ultralight 2.0 for the most simple case, because you just need to run send observation, then the device ID, right, that you copy from the previous command, as you saw before in the register device. The device ID was the host ID and sensor 1. So here you send observation to the host ID sensor 1, and then with simple quotations, T bar 26, and then you send the temperature. And this gets to the IoT agent. The IoT agent translates this into NGSI, and it gets to the context broker. So any developer interested on your entity will get the information automatically if they query this entity or if they are subscribed to changes, etc. So once you have sent the observation, the next thing would be to read the observation. You should be normally reading the observations from the context broker, but there is an intermediate command for debugging purposes that reads the observations from the IoT agent itself. It's called read observation, and you just need to clarify the device ID. And it provides you with the latest measurement. That is 26, because in the previous one we sent 26. Then, how you would be reading the information from the context broker? Well, you can use all the information that Fermin provided yesterday, but in these FIGWAY tools, you have also Python scripts to access the context broker. So there is one folder specifically for this that is called context broker. And if you move there, you will see the get entity command. And there you provide the entity ID, and you just get the whole information regarding the entity. There is also another script that is get entity attribute, and then you provide the entity ID and the attribute ID, and you get just that attribute. So it's extremely simple. As you can see, to work with sensors or devices this way is extremely easy. You just register them, you send the observations, and then you just read the observations in the context broker. And anyone will be able to read these observations in the context broker if you are providing the entity ID to them, or if they manage to discover the entity ID, okay? Maybe because you are providing a meaningful name, as we said before. So I was creating, as an example, a temperature sensor, but you may say, what if I want to create another kind of sensor? Well, the first thing is that we have a number of device models already created in the Open IoT service. So the first thing would be to check if there is a model that is useful for you. So there is a Python command that is discover models, and with this you retrieve all the models that we have, right? You can see down that there is a number of device models: hum for humidity, lum for illuminance, move for movement, temp for temperature. There is another for temperature as well, and then a FIWARE 4-in-1, which is these FIWARE sensors that measure temperature, light, presence, humidity, and that's it, right? So you can see also how a compound sensor is. And if you feel that one of these models is okay for you, then you just check it with a get model, right? So if you run get model sensor underscore temp, you get the description of a temperature sensor. And the most important thing here is the capabilities. That means the observations that this sensor is able to measure, and then the alias for each one of them, right? So for instance, this sensor, you can see that it has a capability called temperature, and the alias is T. And this is why when I send the observations, I put T bar 26, right? If you would be retrieving the sensor underscore hum, you would see that is humidity, that the WOM, which means the measurement units, is percentage, and you would see that the alias is H. So when you are sending the observation, it's just H bar and the measurement, like 80 for 80%, for instance. And in the FIGWAY, you will see there is a folder called models, and there you have all these descriptions. So you can also modify any of these files and create your own model of device with the next script, with create model, okay? So you get to FIGWAY models folder, you edit any of the existing ones. For instance, you say that you want to create a noise sensor, right? So you get to the file that is sensor underscore hum for a humidity, you edit the file, and where you put humidity, you place noise. For the units, you use dB for decibels, for instance, and for the alias, you choose N, right? And then you run this script, create model, and then you will create this device model in the OpenIoT service or in the service that we have created for you if you are using any other service. And that's it. I mean, it's as simple as this. And we will be seeing how easy it is in the exercises later in the lab. And what if I want to connect actuators, right? We have sensors. Sensors are able to send measurements or observations to the platform. They send to the IoT agent. The IoT agent translates this into NGSI, and then this is placed in a context broker. But if I want to receive commands in my device, how I could do that? Well, there are, you know, one of the issues with IoT, with the actuators today, is that most of the times the devices live in private networks, so they are not reachable, or they are in the dormant state. That means they are not awake all the time waiting for your commands. If they are awake all the time and they are reachable, you just need to code an HTTP server, and you might be able to send the commands directly to your device. In our platform, we support both kind of commands. The push commands, that you send the commands to the IoT agent, and then the IoT agent sends automatically the command to the device or the gateway, because you have an HTTP server waiting for that. And that means that it's always awake and it's reachable. Or we have the polling mode. In the polling mode, you send a command to the platform, to the IoT agent in this case. There is a queue of commands that you can inspect with the debugging command. And then the commands are sent to the gateway or to the device when the device asks for them. So that means that your device or your gateway is asking to the platform from time to time, do you have commands for me? And then you get the commands, right? So when you want to create an actuator, there is a Python script for that. It's exactly as with the others, but there is a device model that is called switch, right? And the switch, it's not just an on-off, it's just a command with arguments. So you can use this model for any kind of actuator you have. If you want to combine observations with commands, then you can combine the files of sensor underscore temp, for instance, and switch. And then you can very easily create a specific model for you that has measurement capabilities and actuation capabilities. Actually, I think the switch has one observation capability that is the status of the switch itself, right? So you don't need to get too far to get an example. And the way you would be creating an actuator is exactly the same way you were creating a sensor with a registered device. The only difference is that now you would be using the device model of a switch or any other if you are creating your own actuator model. Then we choose as the device ID lamp 3, for instance. Say that we are going to drive a lamp here that I call lamp 3. And then you choose an asset name, again, that is more meaningful for somebody. For instance, the lamp number 3 in this meeting room. And with that, you create the device. And again, you get the device ID, asset ID, and entity ID. And then, at the time being, if you want to send commands to this device, to this actuator, you just send the commands to the IoT agent, right? In the future, you will be able to trigger the command just updating an attribute in the context broker, right? All the development stuff that we needed to do for this is already done. It's just a matter of configuration. But as we were busy with the IoT agents development, we didn't want to put this complexity now, right? So now you have to send the commands to the IoT agent, and for that you can use this Python script, which is called send command. Here you use the asset ID, not the device ID, because you are more in the northbound. And then raw command and command are just words that you need to use, right? Always the same way. And then with single quotations you use command. And command is any command you want to send with the arguments. For instance, say that I'm driving an RGB lamp that I can send the 3 colors, the red, the green, and blue, and then it sets to that color. So I may use send command, then the asset ID, then raw command, this is always the same, and then set 95-10-23. And then my device or my gateway is supposed to understand this command set with the 3 numbers to drive the lamp to that state, right? And this is all. We are providing for the device or the gateway, we are providing a Python script to get the commands that we call get pooling commands. So if you are creating from your laptop a virtual actuator and you have sent the command, you run now get pooling commands and the device ID, and you will get the command. So in the previous case, you get the asset ID and then raw command bar and the command that you sent. That it was set and the 3 numbers with a hyphen in between. And we are providing as well another script for debugging purposes that is called debug command. Then you put here the asset ID, and then you get the full list of commands that you have already sent to the device. And you can see the status. In this case, it's delivered because the command was delivered to the device. But if it's waiting, then it will be in the waiting state. If there is error or whatever, you will see error here. And you can see a timestamp of the last change of this status. And that's it, okay? So this is the only thing that you need if you want the first contact with the Ultralight 2.0 IoT agent using the Python scripts, right? When you explain this, it looks like a difficult thing, but it's not. It's just to run the commands, to put the asset IDs, device IDs that you get in the first registered device, and that's it. Any question so far? Yep. I don't know if you can get a micro or I can repeat the question. Yeah. Yeah, there.
I don't know if it's a question for you, but it seems a bit not scalable to name sensors or even entities, call it Madrid, because there is another Madrid in another part of the world and another Santander. So are you envisaging any plan to solve that issue?
Well, normally you think that this is a testing service, the Open IoT service, but normally you would be using a specific service for you. I mean, for the city of Santander, we are providing a specific IoT service, right? So you are not placing any device sending information to that service. So when they choose the service name, and then when you get to the context broker, you are only able to see sensors or devices from Santander with that name, right? So there is no scalability problem as long as you are using different names, different service names. You say that there are cities in the world with the same name. Yes, of course, but the letters still arrive. the post letters still arrive to the right city. I mean, this is because you append something else. I mean, if you are in Madrid, Mexico, then maybe you should choose Madrid point Mexico as the service name. But if you are choosing Madrid, Spain, maybe you should be using Madrid point Spain.
Yes, but I want to publish that information on the same context broker, but even it seems that you are choosing some kind of random strings. I could put Madrid / Mexico, but I could put Madrid _ Mexico, or it seems there is no a common way of naming the entities.
Yeah, I get your point. Well, this is a story more related to the context broker itself, right? But this is a design selection that we made. There are many platforms that they have a semantic model, a very strict semantic model. And then you don't get into these problems that you mentioned. But at the same time, they are not scalable in the other sense, that when you want to change something, then maybe your criteria are not enough for that. We choose the other option, to go the other way around. I mean, the IoT integrators, the one that is deploying an IoT scenario, choose the name, right? And we coordinate at the northbound, at the context broker. This means that they need to agree on common names, right? But normally you are using the same platform. So let's say you are using the FIWARE lab. In the FIWARE lab, there is a responsible for the context broker. So this is the one that will be letting you know if you are getting into the trouble, right? But say that you are using, I don't know, a FIWARE node that is not the FIWARE lab. Let's say the Brazil FIWARE node. And let's say that in Brazil, they don't want to go this way, but they prefer to have a very strict semantics, as you mentioned. Then they publish the semantics, and they require everybody to get into their node to fulfill the semantics. Then it works, right? So it's up to the FIWARE node responsible to determine if there is a specific semantics or not, right? For instance, at Telefónica, our commercial platform is based as well in the context broker, in the same context broker that you find out in GitHub, and in the same IoT-Agents that we are developing right now. We go some versions behind, of course, but we use them. And for that IoT commercial platform, we have our conventions, right? And everybody that are using the platform, they have to stick to these conventions. But in the FIWARE lab, we thought that it's better to test in the other way around, right? But it's up to the FIWARE node.
Is the security token attached to the asset? So in other words, do I need a security token that matches the asset, or is the security token one thing and is the asset something else? So in other words, Gabriel and I are both using the same system, and we both want to write to the same asset. Can we each use that with our own authentication token, or are the two really bound to each other?
Well, the token, there are two things, right? There are two security mechanisms implicitly described here. One is the OAuth 2.0 token that was explained before, and this is something that you use as a user to access any of the GEs normally. So when you are accessing the IoT agent, the API of the IoT agent from the northbound, right, for all the management operations, reading, etc., or the context broker, you are including the OAuth 2.0 token in the HTTP headers, right? But when you are a device, you are in the southbound, you are sending up north your observations, you are not using OAuth 2.0 security, at least at this point. You are using just the shared secret, that is the key, the API key, we call this the API key, for the service that you want to use. So say that you want to use the open IoT service, then we are providing the API key in a public way to all of you, because we want this to be open. But let's say that you and your colleague, you are sending information to the same service. Then both your devices would be using the same API key, right? Because you are publishing in the same service. But later on, of course, you can configure different roles to read one sensor or the other, because this is totally decoupled, right? One thing is to send information to the platform, and another thing is to read it. You might have a user that is able to read your sensor A, but not the sensor B, right? Because maybe they are in different groups and they have different OAuth tokens. So then the platform knows if they are able to access one, but not the other. Is it clear?
But is that a future thing, or has it been implemented already?
No, it's implemented, yeah.
So in other words, if I access OpenIoT with a certain API key, I can only access a certain asset.
If you are a device, as
Yes.
you have the API key,
Yeah.
you can publish some information always because you have it here, right? And now, if you are a FIWARE lab user, you can read the information from the context broker using your OAuth 2.0 token. Has nothing to do with the API key. The API key is only to publish information as a device.
But what I'm trying to say is that if somebody has an API key, I'm just looking from a security perspective. If you have an API key, you can publish to any asset in the same machine. So you could override somebody else. We just had the discussion like maybe another Madrid. So maybe somebody may choose the same asset name from the same city, ending up with the same name, and started publishing data to actually what was your asset, and now it becomes my asset.
That is correct.
Yeah.
But the solution for that is that normally you are not. I mean, the OpenIoT service is just to get in contact with the platform, right? But normally, say that you have a company and your colleague has another company, and you don't want him to override your asset ID. I mean, you don't want to agree with him on the asset names. Then I create a different service for you. There is no problem. I mean, there is a total flexibility. If you trust your colleague because you are in the same company and you talk to each other and you agree on the asset IDs, then it's okay.
No,
right?
but
you use the same API key. But if you don't trust your colleague because he's not in your project, then we create a different service for him, and that's it.
No, but I was thinking that the service OpenIoT was an OpenIoT service just for anyone in the world to use to publish their own data. But apparently it's not.
It's just a testing service for hackathons, etc. And this is why there is a. Let me go here. I get your point. For the IoT service, you have this host ID that we append in the beginning, that we prepend this in the beginning of each asset ID. So only your devices have that asset ID, right? So you will not collide with any other. We use this for the hackathons because we are using the same service for everybody, right? So say that you are using your computer, you will be using this host ID, and another one will be using another host ID.
But that's just you're putting some sort of randomness in there. Because we all know that in this room there may be two people that have the same MAC address on their computer, at least for the last 3 bytes. It's not a unique identifier. So you make it sort of unique, but it's not unique. It's more you're more lucky if it's unique than anything else.
And what is the problem for that?
No, but then it could happen that we are in the same room, that two people start up two devices, and they say we measure temperature. This is our host ID, and we're all in Madrid. And at that time we have two colliding devices.
Do you know the probability for that?
Well,
to get the same 3 lower bytes in this room, you have calculated that?
Oh, but it's probably one.
It may happen, yes.
It's a better probability than playing the lottery. I'm telling you.
Yeah. Okay. Well. Then maybe for the labs today, you can use the full MAC address, and then that's it. If you feel scared with the probability. So more questions here?
Hello. Are you considering to use WebSockets in order to send commands to the devices? If we are considering WebSockets, well, we have the MQTT IoT agent that would play more or less the same role for you. Right? We have not considered to use WebSocket with the HTTP, with Ultralight 2.0, because if you are in that case, maybe it's because you want to receive commands directly when you are not in a reachable network, and for that you would be using MQTT standard, right? So if you go for that, I would say better use the MQTT. That is exactly that. I don't know, you know the specifics of MQTT? No, I don't know.
MQTT opens a permanent TCP socket to the MQTT broker, which is the IoT agent in this case. And this is why you have bidirectional communication. So it doesn't use HTTP, it's just TCP, It's a TCP socket, but there is a version of MQTT that uses WebSocket as well. But the one that we have is a TCP socket, yeah. Okay, thanks. Actually, the WebSockets are not exactly HTTP sockets, as you know, because they have to downgrade to TCP, because an HTTP socket has a limited life. It's a trick of HTTP socket. It's a TCP permanent socket.
You send a configuration command to when you send a configuration command to a sensor, pulling you
with a polling mechanism.
Polling mechanism to a queue, you have a subscription to know this configuration command is received in the moment he is via a context broker or IoT agent.
You mean?
I'm
not sure to understand your question, but let me say to check out if I did. You have the polling mechanism scenario. You have a device, you have the IoT agent, and now you send a command to the IoT agent. The command is stored in a queue in the IoT agent. And it's there.
I want to know when the sensor gets that command and actually updates his configuration.
All right. Yeah, you mean if there is a subscribe mechanism in the IoT agent to get notified that it was delivered? There was in the past, but we have cancelled this because, as I said before, in the future, but this is not now, you will be sending the command just updating an attribute in the context broker.
So
and then there will be
context broker proper subscribe model to get that information.
When we will document this, you will see that for each command there is another attribute that is the status of the command that you send, and you can subscribe to that attribute.
Okay.
Right? It's not configured at this time. It's not a development effort, right? It's just to configure the context broker for that and the IoT agent for that. But as long as we have released the IoT agent so recently, we didn't want to try in the beginning.
Okay.
I will keep on now to explain the HTTP calls, because I think we have still 10 minutes, right? So, is everybody fresh? Am I going slow enough?
Yeah, that's okay.
Thank you. Yeah, well, this is why you have the right to say. So, what happened when we were running these Python scripts? Well, actually, you don't need to run these Python scripts. You could be using this from any other platform, from your favorite language, Java, Node.js, C++, etc., or the embedded device platform that you're using, a Contiki OS in a device or whatever. So if I go to this row using model, how I would do the same thing. There are 4 steps that are similar to the 4 steps that I was doing before with the Python scripts. The first one is to create a model. So you have to create a device model. The second is to create the device in the platform, the logical representation of the device. This is what we were doing when we were running the register device command. And of course, you need to use a previously defined device model. This is why you have to create the model before. And then the third step is just to send the observations, and the fourth step is to send commands in case it's an actuator. So here you have all the details of the IoT agent, the IPv4 address, the IPv6 address, the API for the devices, which is the ultralight 2.0. This is when the device sends things to the IoT agent. This is listening at 8002 port, only in IPv4. And then you have the admin API, which is all the other commands. And this is listening in IPv4, IPv6 in the port 5371, right? Then you have the testing service with this API key. But again, if you need a specific service, we create the service for you. It takes, I don't know, some seconds for us to do it. So it's not a problem. We have been doing this even in the hackathon. So really, if you really need a service, it's something that you can do. If you if you are very scared that you will collide with somebody, then you can do it. And then, how you create the model? Well, it's just an HTTP post, right? With a content type application JSON. In the XAuth token header, you place the auth 2.0 token. And in the payload, you have to put here exactly the same files that we have in FIGWAY to create models, right? So it's just the name of the device model, the capability, and then the alias. These are the important things. So it's very easy that you modify this, you make another HTTP post, and that's it. This is only in the beginning, when you need to create the device models. And actually, if you are using a device model that is already in the Open IoT service, you don't need to create that. If I create a new service for you, say that you have a company, right, that is called company 2.0. Then I create a service for you, company 2.0. Then you need to create the models, or you need to ask me, create the same device models that you have in the Open IoT service, and I can do this for you, right? You can run also from the Python scripts. And you could be doing this with this HTTP post, of course. Yeah. It's two things. It's a public instance of the Ultralight 2.0 IoT agent in the cloud, in the FIWARE lab, and with an open service, which is called Open IoT. But in the same IoT agent that is in the cloud, I can create a private service for you. Because if I provide only the API key for you, you will be the only one providing devices to publish information there. And if later on, in the context broker, if it's a private context broker, not the public one, then you select that only people with this role are able to access my devices, then these devices will not be public as well, right?
But in that case, the URL would be services / another string / code.
Exactly. Yep. Yep. Good point. HTTP post to that URL, right? The IP address and the port are the same one because we are using IoT, the IoT agent as a service is always the same one. The URL is M2M, B2 services, and then the service name, and then models to create the model, right?
But when you create a specific service, it only supports one kind of IoT agent, or can the same service support more IoT agents?
Different IoT protocols, you mean? Yeah, when you are using the Ultralight 2.0 IoT agent, you are only placing Ultralight 2.0 devices. Yes.
The IoT agent is associated to that service, or a service can be associated to many IoT agents.
At the context broker level, there is the service naming convention as well, right? When you use a service name here in this IoT agent, the service at the context broker is the same one. That means that in other IoT agents, you can use the same service name, and then you will publish to the same service, right? It could be a little bit tricky with the permissions. I mean, maybe we need, as the FIWARE lab responsibles, we need to perform some configuration for that you are able to write to the same service, because these are two different IoT agents. But this would be our stuff, not your stuff, right? Ideally, you could have the same service in different IoT agents with different technologies, and they would be publishing to the same service as the context broker. So that would be independent of the technology. You have to see that we have chosen all these things to be the more flexible that we can, right? And this is why you are able to do this. If we would be using very strict conventions, like the services when you use Ultralight 2.0 in the context broker are the name of the service -Ultralight 2.0, then you could not be doing that, right? This is why we don't have strict conventions, because then virtually we are able to configure anything we like. The only thing is that you have to agree on that thing. But this is in our FIWARE node instance. In another FIWARE node instance, it might be different. More things? Okay, so once you have created the model, you have another call to create the device itself. So instead of register device Python script, you can make this HTTP post to the same API port. Now is M2M, B2 services, the service name, Open IoT, or another one if you're using another one, and now assets, right? Because you are creating an asset. And here, the same thing that I said before applies, that you need to have a device ID and an asset ID. But here you don't have this host ID protection that I mentioned before with the Python scripts. So here you would need to be very careful, right? That you choose a device ID, asset ID that is not colliding with anyone in the room. If we would see that this is a problem in the hackathons, we would be choosing different services, right? But normally, the people, when we recommend that they prepend a string, a unique string before, they normally do it, right? It depends how good the pupils are then. So then once you have created the asset or the device, then you might be using the device sending measurements. And for that, and now think that you are using the southbound API, you are targeting the IP address, the same IP address, but it's another port, is 8002, because now you go from the device to the IoT agent. And here you are coding in the URL as well the API key and the device ID, right? And here is the device ID, not the asset ID. As a mnemotechnic, you can use the rule that whenever you are going from the southbound to the IoT agent, you will be using always the device ID. If you are using the northbound API of the IoT agent, you would be using the asset ID, right? That is the trick to remember. And then in the payload, you just include T_25. So you can see that is pretty similar to what we did with the Python script. If you have several measurements to be sent in the same packet, say that you have a SafeWave 4-in-1 device, you just need to include a hashtag in between them. So if you want to send temperature, humidity, light, and movement, you can send T_23 #H_80 #L_95, etc. And if you are sending commands, here I include the documentation to send push commands as well, but I don't consider this very important, right? Because the added value is more in the polling commands. As I said before, if the device is always waiting for commands and you have an HTTP server there, you can send the commands directly to the device. So the push commands facility at the IoT agent is not so relevant. But the polling one, it is. And for the polling one, you have 3 calls. First, the call to create, to update the asset so it can receive commands, right? That is one on the left-hand side of the slide. And then there are 2. Once you have updated the asset to receive commands, you have the post in the bottom of the slide, so you can send commands to the IoT agent. And this is HTTP post, IP, and the 5371 port, because this is the IoT agent API. M2M, V2, services, the service name, assets, the asset ID, and then command. Okay, that command literally, not the command that you want to send. And then later in the payload, you put all this stuff, right? The command with the parameters and values, right? So normally, as a command, we use command. As parameter, we use command. And as value, we use the arguments of the command, right? You can see that in the examples in the Python scripts. And then later from the device, and that is using the southbound API of the IoT agent, of course. You use the IP, the same IP, and 8002, because it's the southbound API. Then you use the API key as well, because the device knows this secret for this service, and the device ID. It's actually the same URL as when you are sending observations, but instead of a post, it's a get verb. And that's it. With that, you would be getting the commands. And I will finish here, right? Any question? Sorry? Sorry? The link of the presentation. Let me, I think there is a previous version of these slides that is, I would say 90% these slides in the slide share. So if you search FIWARE IoT, FIWARE IoT, you should be finding the last one. But I will be uploading this one just in a few minutes in the FIWARE SlideShare channel, right? I think they are also in my SlideShare channel, but I prefer that you use the FIWARE one.
When the data gets stored in the context broker, it automatically gets time-stamped for when the data was received?
True. It's part of the metadata we are sending. Yeah. You?
If you send a command, if a device asks for the status of that command, is it marked as delivered? Like if you posted a command and then something does a GET request for that specific command, will it get marked as delivered once the first GET?
You're asking if it's idempotent in the end, no? If you request from the device the command several times, if you get it or you get it once.
Just is there something that says that that command was delivered after a GET request has been
Yes, with the Python scripts, you have this debug command, right? And actually, this is an HTTP GET request to the API of the IoT agent. It's documented in the documentation, but I didn't place it here in the HTTP posts. But if you are using the Python scripts, you have. Let me go here. You have this debug command, and you can run this command from any place. I mean, from any debugging platform or computer, but also from the device itself.
So the status delivered is it's marked as delivered after the first GET request.
Exactly. Exactly. And if the device asks for the command again, do you have more commands for me? It will say no, there are no more commands.
So it only delivers.
It delivers only once.
But if you just send a post, just to send data, what you get back is a status 200, or are you getting more data back?
When you send the command to the IoT agent, what you get is a 200 OK, and then that's it. Yeah, that's it. Yeah, then you should be using this debugging facility to check every time the status. And there is no subscription for that, as I said, for your colleague.
Now, the reason why I'm asking is we do a lot of traffic over the GPRS data network. For every byte.
Yeah.
So what I would like to reduce is the number of bytes being sent. And to me, it's really ridiculous to send M2M, V2 services, OpenIoT. That whole bit of data is not necessary because it's already uniquely addressed by 5371. And again, I want to get as little data back as possible to keep everything lean and to run it within your data budget.
I fully agree with you. For the case of constrained devices, and well, GPRS is not considered a constrained network, but let's say that it is in my case because I pay for that or whatever. Then what I would be doing, I would not be using anything over HTTP, because when you use something over HTTP to send 20 bytes, you are sending 1K, right? So the problem is, your problem is not the URL. The problem is the HTTP protocol. And this is why we are providing, an IoT agent for lightweight M2M over CoAP. As you know, CoAP is the rest over UDP, right? When you send 20 bytes over CoAP, you are not sending 20, but you are not sending 1K as well. You're sending 64 or 2 blocks of 64, as you know, perhaps. And actually, when you are using lightweight M2M over CoAP, you are reducing the payloads and the URLs, because you are using number codes that are in the Open Mobile Alliance directory. So if your problem is that, I would say don't use HTTP 2.0. Your problem is not ultralight 2.0. Your problem is HTTP.
That's why we're hoping that the co-op gets delivered really quickly.
Then stay tuned on Thursday. My colleague Daniel, that is actually here. Daniel, raise your hand. He will be explaining my favorite IoT agent that he coded himself, right? That is the lightweight M2M over CoAP. And then I will be using that, right?
Thank you.
More questions? Thank you very much for your attention.